Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage and resistors. This exercise was a previous one in the previous exams in 2016 first session second exercise. The title of this exercise is Nature of an Electric Component. In order to determine the nature of an electric component D, we connect the electric circuit of the adjacent figure. They mentioned the adjacent figure. So now we can use it. This circuit includes in series a generator G maintaining across its terminals a constant voltage of adjustable value. So adjustable value means that the voltage of the generator can be adjusted, can be changed, and this arrow on the generator means that it is of adjustable value. A digital ammeter A of negligible resistance, the electric component D. Number 1. They are telling me redraw the diagram of the electric circuit and indicate on it the terminals A and COM of the ammeter in order to display a positive value. First, let's draw the given electric circuit. This is the battery. This is the ammeter. This is the electric component D. This is the point C, this is the point B, this is the point P, and from N to C, this is the generator G of adjustable value. Now we need to indicate the A and COM terminals of the ammeter in order to display a positive value. So positive value means that the COM terminal is connected to the negative pole. This is the negative pole. So going to the ammeter, so this is the COM terminal and this is the A terminal. Now in number 2, they are telling me in order to measure the voltage UBC across D, this is the electric component D, we use a digital voltmeter, part A. Represent this voltmeter on the redrawn figure indicating its V and COM terminal. So this is the voltmeter. Because the voltmeter measures the voltage, then it must be connected in parallel. Connected in parallel across D because we are measuring the voltage across D. Now it's left to indicate the V and COM terminal of this voltmeter. Notice that in part 2 they are telling me in order to measure the voltage UBC. And we know that always the COM terminal is related to the second letter. So in this case the COM terminal must be connected to the point C. So this is the COM terminal and this is the V terminal. Because the voltmeter is measuring the voltage UBC, and we know that always the second letter is for the COM terminal. Then the COM terminal must be connected to the point C, which is here, and the other terminal will be connected to the other point. Then done for part A. Now in part B they are telling me UPB is equal to 0 volt, justify. Across the terminals P and B we have an ammeter, but notice that here the ammeter is of negligible resistance, therefore the voltage across the ammeter is 0 because it is of negligible resistance. Now in part C, or let me write here the result. So UPV is equal to 0. Now in part C they are telling me show that UPN is equal to UBC, and this can be done using law of addition of voltages, because in part B they ask me about the voltage across a certain branch. Then let's say apply law of addition of voltages. Then how do we apply this law? Always on the left we write the voltage of the battery, which is given by UPN, And on the other side we'll write the voltages across different electric components, starting from P and ending with N, and making sure that UPN and UBC will appear in the equation. Then from P we will go to the point B, from B we will go to the point C, and from C we'll go to the point N, making sure that UPN and UBC must appear in the equation. Then we will keep UPN as a variable. UPB is equal to 0 justified. We will keep UBC, and UCN, across C and N we have a connecting wire, so it's 0, and here between brackets UCN is equal to 0, and the reason is given by connecting wire because we didn't justify this previously. Then we have that UPN is equal to UBC. Let me make some space here. Now in part D they are telling me the voltmeter displays a positive value, justify. Notice that here the COM terminals of the voltmeter is connected to the negative pole, which means that the voltmeter will indicate a positive reading. Let's say since the COM terminal then the voltmeter will indicate positive reading. One could answer this question in another way, relating it to the previous part. So it's always better to answer the question relating it to the previous part. So let's say or in the previous part we have proved or show that UPN is equal to what? UBC. Okay? So let's say here, since the voltmeter is measuring the voltage UBC, and this is because of the given and number 2, the voltage in order to measure the voltage UBC across D. But we have proved that in part C that UBC is equal to UPN, and the voltage UPN across the generator, because we are measuring the voltage from the positive pole to the negative pole, so UPN is positive, which means that UPN is positive. So the voltage measured by the voltmeter is given by UBC, which is positive. Then the voltmeter measures positive value. Now in number 3 they are telling me we vary the voltage UPN across the terminals of the generator. The adjacent curve gives the variation of UBC as function of the current I in the circuit. They mentioned the curve, so now we can use it. Notice that this is the curve and it's being plotted in the current voltage system. Although this is a straight line passing through the origin, but we name it a curve because in more general cases this straight line may be a curve. Now in part A they are telling me the X resistor, justify. Notice that this curve is a straight line passing through the origin, this is important. Then the electric component D can be considered as a resistor. Then we are in 3 part A. Since the characteristic, let me say here current voltage on a new line, curve is a straight line passing through the origin. Then D can be considered as a resistor. Now in part B they are telling me determine graphically the value of the resistance R of D, and this can be done using the slope method. So first let's try the definition, which is given by the resistance of the resistor is equal to the slope of the characteristic current voltage curve. Now the next step is to choose any 2 points belonging to this curve. Let me choose here the point A, and for example let's say here the point B. Then the point A holds the following coordinates. We always write the current and the voltage. So the point A has a current 0.02 amperes and a voltage given by 1 volt. As for the point B, it has a current given by 0.08 amperes. As for the voltage is given by 4 volts. Now here no need to change these values to the SI because they are already in the SI. Now we are ready to calculate the slope, which is the resistance, and it's given by R is equal to the voltage of the point A minus the voltage of the point B over the current of the point A minus the current of the point B. Here it doesn't matter in which point we start, but the important thing, if we started with A, then in the denominator we must start with A. If we have started with B in the numerator, then we should start with B in the denominator. Then it's equal to 0.02 minus, Now the voltage of the point A is given by 1, and this can be known from the unit. So 1 minus the voltage of the point B, which is given by 4, and this can be also known from the unit, minus the current of the point A, which is 0.02, minus 0.08, then minus 3 divided by minus 0.06. The minus goes out with the minus, and this will give us 50. Since everything is in the SI, so the value of R will be in the SI, which is ohms. Then the resistor R of this electric component is given by 50 ohms. Now in part C, they are telling me D is replaced by 2 resistors connected in series and of resistances R1 is equal to 30 ohms and R2 is equal to X ohms. Then R1 and R2 are in series, and actually they replace the electric component D, which also considered as a resistor. So now instead of having the electric component D between the points B and C, we have 2 resistors given by R1 and R2. Then this is R1 and this is R2. The value of R1 is equal to 30 ohms and the value of R2 is equal to X ohms. They are telling me to calculate X such that these 2 resistors replace the single resistor or the electric component D, and this is known as the equivalent resistance. So R must be equivalent to R1 and R2 because they are in series. Then R is equal to R1 plus R2. the value of R is given by 50, and the value of R1 is given by 30, the value of R2 is X, then we are interested in calculating the value of X, knowing that this is a linear equation and one unknown, which is X, then X is equal to 50 minus 30, which is equal to 20. Then the value of X is equal to 20. Notice that always in physics all quantities must have unit, and whenever we don't place a unit, it must be justified. Notice that here R2 is given by R2 is equal to X ohms, and the unit is not included in X, it is outside of X. So here we don't place any unit inside of X, or simply we can say that R2 is equal to 20 ohms. Because suppose that if we have placed for X unit, which is equal to 20 ohms for example, and now R2 is given by X ohms, which is equal to 20 ohms. The first ohm is for the X, and the second ohms for this, which will be equal to 20 ohms to the power 2, and this is not the SI unit of the resistance. It's not unit of resistance at all. Okay? And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.